Have you ever felt a zap when you touched a doorknob? That's electric charge in action. Almost everything around us has electric charge. It's a fundamental property of matter, just like mass. Electric charge comes from tiny particles inside atoms called protons and electrons. Protons live in the center of the atom, the nucleus, and have a positive charge. Electrons are always moving around the nucleus and have a negative charge. Electric charge is what makes things stick together or push apart. Opposite charges, like positive and negative, attract each other. Like charges, like two positives or two negatives, repel, meaning they push away from each other. This attraction and repulsion is what causes static electricity and makes lightning. We already learned that protons have a positive charge and electrons have a negative charge. An object with more protons than electrons will have a net positive charge. On the other hand, an object with more electrons than protons will have a net negative charge. We measure electric charge in units called coulombs, named after a cool scientist named Charles Augustin de Coulomb. The symbol for coulomb is a capital C. 1 coulomb is a huge amount of charge, way more than we usually see in everyday life. Think about rubbing a balloon on your hair. The balloon steals some electrons from your hair, giving the balloon a small negative charge. Your hair, now missing some electrons, has a small positive charge. Now, let's talk about some important ideas related to electric charge. First up is elementary charge. This is the smallest possible amount of electric charge, and it's found on a single proton or electron. It's a teeny, tiny number. Next, we have the conservation of charge. This is a fundamental law of physics that says electric charge cannot be created or destroyed, only transferred from one object to another. Remember that balloon stealing electrons? That's conservation of charge in action. Finally, we have Coulomb's law. This law describes the force of attraction or repulsion between two charged objects. It tells us that the force gets stronger as the charges get bigger and weaker as the objects get farther apart. Some materials let electric charge flow through them easily while others don't. We call materials that allow charge to flow conductors. Metals like copper and silver are great conductors, which is why we use them for electrical wires. Materials that don't let charge flow easily are called insulators. Rubber, glass and plastic are good insulators. They protect us from electric shocks. Think about the rubber coating on electrical cords. That's an insulator keeping the electricity from flowing into you. Static electricity happens when charge builds up on an object, usually an insulator. Remember that balloon and hair example? That's static electricity. The balloon, an insulator, builds up a charge when rubbed on your hair. When you touch a metal doorknob afterward, zap! The built-up charge suddenly flows, giving you a tiny shock.